Okay, welcome back, everybody. Let's get started. So the plan for today is to finish off what we couldn't finish on Tuesday. So we'll be going into the D3 details. And then we'll follow this by finishing up the perception lecture. So this is going to be like a class, like a bit of mixed class. And like originally planned, I had data for today, but I'll probably combine this with the marks and channels on Tuesday. And then on Thursday, one of our TAs, or teaching mentees actually, a PhD student, Tripti, she will be teaching on maps, which is something that you'll be needing for the next homework. Well, not for the next homework, but for homework 4. And then the following Tuesday, I'll be out of town. And so one of my PhD students who's actually doing research, Max, I'm not sure whether he's here or not, but he's working on a Chi deadline. And so he'll be talking about design, like design guidelines for visualization, because it nicely aligns with his research. And so he's kind of like the expert on this topic. Any administrative questions before we get started and dig into D3 again? Okay, great. So let's start a little bit with a recap. We again went over most of this, but I want to look at it in a little bit more detail just to make sure that everybody gets this concept because it's so important. As you remember, D3 is about binding data to elements, and we bind these data to elements by first creating selections and then doing a data binding, and then we can style these elements based on the data that has been bound to that element. And so recall that we can select or select all in D3 based on elements, like for example, D3.select SVG based on classes, for example, D3.select all.class name. Or based on IDs, D3.select, in this case, select would be better than select all here, cancel button, right? So these are the different ways of how we can create a selection. And here we have like a simple example. What we have in HTML is some text. We have P's and nested spans, but no styling. And then we take D3 to manipulate the styling of this nested text here. And in this case, I'm doing this child selector. Remember from the CSS lecture that I can do these kind of like dependency selectors. So here I'm selecting all of the spans that are directly children of the paragraph. This is just to demonstrate that any kind of like CSS selector code that CSS understands can actually also be used here in the D3 selection. So this isn't particularly new. Here we set the span selection to style color steel blue. Nothing particularly surprising. But what I really want to look at here is a little bit more detail on what is going on behind the scenes. So what I'm printing here is our selection. And so this selection, this is this object that we can use declarations on to change all of these elements. And of course, we can look at the D3 source code to kind of like learn everything there is to learn about. But we can also, just for like some quick intro, we can simply print the selection and see what is actually in here. And so what we see here is there is a groups array, and the groups array is kind of like our update selection. And if you look in here, we see the 3 span elements, right? And they're actually identifiable. And so this is like what D3, like what is really contained in that selection. And then we can look at the span object. And as I mentioned, like behind the scenes, any HTML element has lots of attributes, right? We can kind of manipulate these attributes. And we can also look at these attributes here in the console. So we can see like all of these different attributes that are like partially that are like based on HTML span attributes, partially they're probably like supplemented by D3 in some sense. And so yeah, we can see like all of this information about this object here. So if you ever need to debug or need to learn about what's going on in here. So this is kind of, as I said, the update selection, what's in these groups here. You also see some other information like the prototype object and so on, like remember prototypical inheritance, and you can look at the parents and so on. So all of this is great. Now let's look at what this means if we map data. Remember that we said the idea of D3 is to be able to bind data to objects. So I can take the selection and to bind the data vector onto it. And so this is what we're doing here. We're selecting, like here, I'm starting out with these 3 rectangles here that I then want to style and position based on some data. See that they have like uniform height and width, and they have like basically gray styling, default styling here, light gray from the rectangle CSS stuff here. And then we like select all of the rectangles. We look at the selection, then we bind the data to it. We look at the data, and then we do something with the selection, our attributes-driven styling. And so recall that the important part here is that once we've bound the data to the selection, we can retrieve it in these kind of like styling functions by passing in a callback. And we usually do this callback by passing in an anonymous function, usually also with the arrow notation. And that anonymous function takes at least, well, it's useful to pass in 1 or 2 parameters, the D and the I. The D is the data payload. The I is the index of that element that you're currently operating on in our selection, right? And then we do something. In this case, we really only use the I. And in this case here, we don't need the I, so we don't need to put in this parameter. Remember that in JavaScript, you can like, even though a function has a specified signature, you can pass in only a subset of the parameters, and that is legal. That's why this is actually a legal operation, right? I don't have to specify D and I, even if I don't use the I. And so here I'm simply styling this by the width, right? And so if I execute this, I get our bars here. And so the interesting part that I wanted to show you is now we have these selections here explicitly called out, the enter, the exit, and the groups. And this is now because earlier when we just had a selection and we didn't have a data binding, of course, if you don't bind data, there is no enter and exit selection, right? There's only the update selection or the group selection in this case here. These are like, if you print it like this, they're gonna be empty because like what's actually being printed here is the object. So if you went in and printed the properties, you would see what is actually in the enter selection. But if you print it like this, where you print out the object and dynamically explore it, you will actually not be able to see the enter selection in here quickly. But we can see well, there's actually also in this case no enter selection, but we can also see the groups. And so here in our groups, aka update selection, we have the rectangle elements, right? And so now we can look at the rectangle elements. And this is the thing that I wanted to show you here. So underscore underscore data underscore underscore 127, right? And if we look at the second one here, it's going to be 61. And not surprisingly, these are the values that I bound here, right? So this is where this is actually stored. This is what's going on behind the scenes. And this is like what is being used when you pass in the D here. And so if you ever wonder, why am I getting a wrong D? Or is something wrong? One way to look at what is actually bound to the object, whether you have really updated the binding of the object, is to inspect these elements directly in here, right? And so remember also that I mentioned this when we had the manipulating HTML just with the standard DOM API, we did this ourselves, right? We directly bound the data object to an element. And so we kind of like emulated what D3 is doing here behind the scenes. Okay, any questions about any of this? Yeah. So the question is whether, and correct me if I'm wrong, the question is whether if I pass in an object, whether this is a static object or a deep copy, or is it a shallow copy, or like. Yeah. So I'm not sure I completely get your question, but essentially, if I want to change something in here, then I have to rebind the data. So I have to call another data binding, and that's actually fairly common, right? Like if I have updating data, then I have to rebind the data element. And so one tricky bit about this is that I'll be talking about later is that if you have like just an array, like you don't exactly know what is what, right? But if you have complicated objects or more complicated objects, you can actually do something about that. I'll show that later. I'm not sure that answers your question. Okay, good. Get back to me at the end of the lecture if there's still something unclear about it. Other questions? Yeah. Yeah. Yeah, I'll get to this in a second if you might. Okay, probably in my next code box is the enter selection. Yeah, so here's just what I showed in the screenshot here. Okay, now the enter and the exit, like this is basically recapping everything that I mentioned before. Let's review this figure again. Like what are the differences here, right? When we have elements in the DOM already that we select and we bind data to them, that's kind of like the easiest case, right? So we don't need to create new elements. We just need to update them based on the data that we have. And that's called like the update selection here. So like the data binds directly to existing elements. So we have existing data that binds to existing elements. The intersection here is the update selection. If we have data that doesn't bind to existing elements, this is kind of then contained in the enter selection, right? These are the elements that we like that are newly added that we have to, for example, where we have to specify that something is a rectangle and so on. And then we have elements that didn't find a match in our data, and this is the exit selection. And those elements typically we have to take care for to remove them. That's often a simple call, like simply say selection.remove. But sometimes you want to do some animation, right? Or you want to fade them out or do something graceful with them. And you can do that if you like manipulate the exit selection. Okay, let's look at this a little bit more in more detail again. So here we have an example with nothing in the SVG, right? So we create our 3 bars from scratch, and this is kind of what we do, where we have to manipulate an enter selection, right? So here we have, remember this select all rectangle here is actually not selecting anything, right? This is this selection on, and like basically that is going to be empty, and this is going to be uninitialized objects initially. And so remember also that like in theory doesn't make sense, or it doesn't need to be rectangle in here, but of course it should be, because otherwise Vadim would be angry. And so here we do our data binding, and then we can look at the enter selection here. And so let's look at the enter selection. I hope this prints properly. Yeah. So now the interesting bit here is that see that our enter selection at this point is not a rectangle, right? It is this placeholder enter node object. So it's a node, but we don't know yet what it is, right? If we have to only specify later what it is. And so that's kind of like the interesting part here. Like this is now a selection on stuff that doesn't exist, and you will see that this is also much simpler. Remember when they had this rectangle? When we looked at this, we had all these hundreds parameters that kind of like HTML specifies for each element. But this isn't actually an HTML document yet, right? Or an HTML element. It's just like much simple. It simply has these very few parameters here, but it has, in this case, the data bound to it, of course, right? So this is an empty node, nothing specified about the node except for the data. And then here, we take our enter selection and append the rectangle. And now this is being replaced behind the scenes with an actual rectangle element, right? And the data is transferred over. And so if you look at this selection down here, with the assigned rectangles, we will see the actual rectangles, right? And that have the data bound to them. And so that's kind of like the magic behind the scenes, that what's going on here. Yeah, so is that clear, or any questions? Yeah. So that's because I'm actually directly printing the enter selection and not the whole selection, right? So here I'm saying data.enter, and I'm storing it in an enter variable. And so I'm not, like, if I print the data, then I would have this in here. So if I do console.log data, then that should be comparable to what I had before. I'm confused because there's so many things. Yeah, probably the first one here should be our data. Yeah, see here we have the enter, the exit, and the groups. Okay, great. So now an example that handles enter and update correctly. So we have like, well, let's look at what we have first. Run creates 6 bars, and then next data set switches it out to another data set with 3 bars, right? So that's kind of like a common thing, right? For example, in the next homework, we'll be looking at some COVID data, and we want to switch between the COVID data for Canada and the United States, right? And so we'll be doing something like this. And so what do we need to do to allow all of this? So first here, this code here that looks a little bit strange is just my implementation of switching between 2 different data sets, right? So basically here, there's a new function that has this new button that simply says next data set. That next data set, when that button is clicked, I'm calling the execute function that I usually call from the run button, but with a different parameterization, right? And so if this here is clicked, then I get the execute function. I pass in data. If there is a data attribute in that function, then it uses this data attribute. If there's no data attribute, then it uses this array. So just a simple implementation of switching out those 2 different data sets. Okay. And then here we have our data binding. And then here we handle the exits, right? So we don't do anything fancy, no transition. We say bars.exit.remove. And then here we handle the enter section. We say bars.enter.append rectangle.class bars, because we want to give them a class, right? Because we want to later select them based on a class. This is what I also do here, right? I'm selecting all bars. Like, that's usually better than using elements, which I used before just for simplicity. But generally, you should select based on something else, not necessarily elements. And then I'm doing the merge here. So at the end, in this bars element, we'll have both the enter and the enter and the update combined, and the exit will be removed, right? So this is our final selection of all of the elements that we want to have. And then here is the first time we actually apply the styling, right? The same styling that we had before, and that allows us to do all of those things here neatly. So then we can switch between those 2 data sets seamlessly. Okay. Sure.
I just want to know that how can I use these meters over the.
So you don't. That's because it's you. So you could, but you shouldn't, because D3 really gives you this way of doing declarative styling, right? So in theory, what I could do here, like if I wrote this as a procedural program, I could say for bar in bars and then apply the style, right? So I could retrieve from the bar. I could receive the __d attribute and use that to apply the styling. But that would be kind of like non-idiomatic, right? It's possible, but it's not actually the way you're supposed to be doing it in D3. The kind of idea, right? This isn't just a standard array, right? This is actually a selection object, and this allows you to do this declarative approach of styling. And so everything that you do here applies to all of the elements in that array. So like you simply say, I want all of those to be green, and you don't have to iterate over it. That D3 does it for you. You simply say green, right? And that D3 goes through this list and applies the green color. And similarly, for data and the indexes, you use the data and the index to manipulate the data as attributes and the index attribute. So you don't have to loop, and actually you will like you shouldn't do that.
What do you for applying a certain color?
Yep.
Suppose green. So I'm not doing that. Suppose if I need something from the node, if I need an attribute,
Yes.
calculate something.
Then you do it with the D. And your D can be a single number, but your D can be an object, right? And your D can be an object that is arbitrarily complex. And so you could have in that, I'll show you an example later, where you have a D payload with 3 fields, where you have a category, a number, and a name, a label. And we'll all use in this D, we'll extract all of those 3 things that we can then use to style this.
Yeah, and then in that case, the first one is Y. Take it B, I. In here, I is present in that list.
I is the index of that element. So that tells us the I here is if you, I is first is 0 for the first element, for the second one is 1, for the third one is 2. Yeah, you had a question?
Yeah.
Like, sorry.
Every time you want to update the data, so say if you have the button data,
yeah.
You have to declare all of those.
You know, if you just want to increment and change the data, then you could use the same function, right? You just use a different data set. So you could, like, basically what I'm doing here is this is completely flexible, right? This just takes an array and draws me a bar chart for arbitrary length arrays or for arbitrary values. So I don't have to redeclare anything in that sense, but just because I'm wrapping it in a function.
I guess there are different the way the function works and for consideration.
No. Yes, and yeah, I think it would be kind of breaking generality. You could make some assumptions in theory about it, but then you would, like, you, for example, if you know that you're not going to get any more elements ever, you could kind of like not bother about enter and exit, right? But you shouldn't make that assumption like for some future call, right? So this is like basically the general way, and I'll show you like this the join way, right? It's even more simple. Then you don't actually have to explicitly deal with enter and exit if you don't want to do anything special, and then you basically just work on the output selection. Yeah.
If one of your elements in the data is somehow based on another, some complex.
As long as you as long as it is kind of contained in that object that you write into D, you're fine. And if that dynamically changes behind the scenes, you might have some weird behavior and hard to track down bugs, but theoretically it's possible. Okay. Yeah. Yeah. So you should probably always use join. The enter, exit, and update are just like A, they're the old way to do it of doing it, and B, I think they're kind of like easier to explain. But if you write your project, you should always use the join. Okay, so here's the join example. So this is the same thing, right? But the big difference here is that the join syntax is a little bit easier. Like in the enter, exit, and update way, I have to explicitly take care of the enter selection and create the rectangle. I have to explicitly remove the rectangle, and then I have to explicitly merge it. And I kind of replace those 3 steps here with a single call to bars.join rectangle. And that what this does here behind the scenes, it takes care of removing elements, of the removing elements that are in the exit selection. It takes care of creating new elements based on the rect here, right? So you could kind of like in theory get into something weird here if you select on something else and then join with, like, for example, I select on rectangles, but then join on something else, right? That would be a weird thing to do. But it could be possible. And then you say, and then you specify all of the attributes at once. And this is kind of like nice because I don't actually have to do this enter, update, exit stuff. But of course, I still can do it if I want to. Like, let's look at this. This works just as well. So this is kind of like, if you, again, in the next homework, you'll be writing a bar chart. And that is kind of like the example that you should base this off, right? So this is kind of like the most efficient way and the most kind of like modern way of doing this. Yeah, I did show another example in the previous lecture where I showed you how you can actually, like, you can specify functions separately for enter, exit, and update. So if you want to do some, for example, fade out, you can still do this with the join. I personally like to write that manually if I do something fancy with enter, update, and exit, but you know, I think it's just as well done with join. Any questions about join and the relationship to the others? Okay. Great. And then we talked about transitions. So what we have here is kind of like some of these nice things that I mentioned earlier. So I first run this, and we see that these bar charts are growing. And then I'm switching it to the next data set. I'm fading some out, and I'm moving the other ones, right? And so this is actually now fairly cheap. Like I can do this very smoothly by simply saying, here is the stuff that I had before with, like I styled our enter selection. And here we have our exit selection. And like, well, what we do here is we start out, the enter selection starts out with an opacity of 0, right? So they're completely transparent. So they're not visible at this point. The exit selection, it begins completely opaque, so completely visible. And then it transitions for 3 seconds to opacity 0. And after that is done, it's being removed from the DOM, right? So what happens is this object is changed to be lighter and lighter and lighter and more transparent. And eventually, when it's completely translucent, it is removed, right? So that's what's going on here. Then we merge both of those things into this one selection. And then we say, if we have an update, we actually want to do like the smooth animation between the size of the bar before and the size of the bar after. And we're doing this simply by by not just styling it, but adding those 2 lines here, saying dot transition dot duration. And D3 is so smart that all of the other attributes that you change now are dynamically interpolated, right? So whatever your X position, your Y position, your size, your color, all of this D3 automatically takes, compares before and after, and does the smooth interpolation for you in the duration of 3 seconds, right? Back before D3 existed and I wrote my own code, this was actually like a lot of work to do, right? So like doing all of this interpolation for all of the different things, that was kind of like a hassle. Well, it was fun to do, but it was like a lot of work. And so now with just 3 lines extra, you get this nice behavior here. Yeah. That's a good question. I actually don't know. I assume it is. Yes. So if I do this quickly. Yeah. So yes, probably is, but it's a good question. I'll look into this and I'll post an answer on the lecture channel. Other questions? Okay. So now one thing that is a little bit tricky to do is when we have groups. Like remember when we had SVG, we talked about groups and how groups are great for combining elements, multiple elements together. And so one usual case for this is something like this. When I have a bar chart and a label, right? Then I want those to be grouped together, because then I can like specify my Y position only once for the group, and I don't have to specify the Y position separately for all of the elements. And so this here works for the first data set, but it is a little bit tricky because the updates, like the data binding, isn't automatically passed into groups. And so if we just do this here, if I click on next data set and run, we can see that I'm removing the elements, but I'm actually not updating them correctly, right? And so this was kind of like the naive way of doing this. I am kind of like, this is with this join syntax now. I am selecting all bar groups. Okay, let's see. We started out with nothing. We select all bar groups, then we bind our data to it, and the data can be either the 6 bars or the 3 bars. Then we have a join, and here's the enter syntax that I talked about earlier. So for the enter, we do this stuff here. And so we say enter append g. So we create a new group. That group is then classed, gets a class that's called bar group. And then to that group, we append a rectangle. And that rectangle we style based on the data. And then we fill it with steel blue. There's like a duplication here, so that should be removed. And then we have the text element, so that we also add that. We move, like this is like the transform here is basically, if you look at this element here, you want this text element to start exactly at that position, right? And so I could either specify the Y position of that element, or I could say for the text element, or I could just like move it over with a transform, right? These are the two options here. And I'm going to use a transform here. And the transform here like has a function like that's based on the D of the group. And that has like this translates D plus 5. So move it over by the size of the bar and 5 extra pixels. So we have a little bit of spacing. And then we keep it on the same Y position. Then we specify the text, what is actually being printed here. And then we specify our Y position. And that Y position here is the bar height divided by 2. Okay. And then we return the enter group. And so here we basically have just the enter. And yeah, the problem that we have now is that if we look at this in the console, let me close this here, I'll work with the screenshot. When we look at this in the console, the group element, when we update this, when we go to the next data set, is actually properly updated. But then the data element that binds to the rectangle isn't properly updated, right? So the selection doesn't automatically down propagate. If I had bound the data to the group and then later done something based on based on this data, it's not automatically available in all of the nested elements. And so to kind of like remedy this, and so here's kind of like how it's supposed to work. Like I run this first, and then I say next data set, and it works just perfectly. And you see that all of those labels also reappear. And so the trick here is, like here I have my enter. This is more or less the same thing as I had it before. But I also have to do an explicit selection of the sub element. So I'm taking the groups that I have, and then I say dot select the rectangles. And this now propagates the data down to the rectangles, right? So at that point, the group element takes the data it has bound to it and propagates it down the rectangle. And then we do the same thing here with the text. And if we do this, and we do also most of the styling of those two elements in here, then we have this robust implementation that propagates down into the sub elements of the group. Okay, and I know this is a slightly complicated, but essentially, whenever you work with a group, which is often a very good solution, and you bind data to the outer group, and something isn't working, just think of this particular example here and look back at what's going on, and you can solve it by explicitly selecting all of the elements that you've nested in here. Yeah. Why would they ever be different? They're based on the data, right? So that they're based on the same data item, based on the same vector. So they're always going to be the same number of text elements as the bar elements. Yes, exactly. I'm creating them based on the data.
Why didn't the actual text move the transition?
Because that's how I specified it. So I didn't want the text to be moving. So here, like this is now again a synchronization. Like, what would happen if I, would you change the text one by one, right? It's not completely clear. And this is actually here the logic of D3 ends. It treats text as text, right? It doesn't know that you're printing a number. And so like if this is kind of corresponds, if I click on next on run here, this is like a bar with 256, and if I click on next, it's a bar with 120, right? So it wouldn't really make sense to keep the 256 until the end and then replace it, right? Like I could implement, like a fancy implementation could kind of like count down the numbers, right? But that would take some extra work.
I guess I was expecting, because you put in transition after telling the text to translate. So I would assume.
Yeah, so in this case, I act explicitly for the text. What do I do here? I'm immediately setting opacity to 0, right? Without a transition first. And so as soon as this happens, it first starts with, it goes to 0. And then only later transitions in with opacity. Yeah. No. It is JavaScript and manipulating SVGs. There is nothing uses SVG, CSS here. So the grouping, what the grouping does, I think that's easiest explained if you look at this HTML here. So what this grouping does here is it creates this one container that contains both the bar and the number, right? So see that my highlight here for the group is like both the element and the container. And so the Y positioning, for example, if I've implemented this nicely, yeah, yes. So here I am doing the positioning of the whole group, right? I'm doing that at one point, and I don't have to separately position the rectangle and the text. That's why I'm using a group here, right? Because I'm saying like your bar within the group, it renders always as it were like if it were at coordinate 0, at Y coordinate 0, right? It doesn't have to know about this because it's contained in the group, and I'm moving the whole group. And so it kind of makes it a little bit easier for the styling here because I'm doing this only one time. Yeah, so here, the enter, I first define the group, I create the group first, and then I add the rectangle to the group. Like I say enter group dot append the rectangle, and then I say enter group append text. Yeah. So the difference here is like I append the enter, like I append the group to the enter selection, but I append the rectangle and the text here to the return value of this, right? Like I have created the group, and then I'm get back this list, this group selection here, and then instead of using the original selection as I used here, I'm using this selection here to append the rectangle. And so this is why it's nested, right? It's group first, and then rectangle, and then text. Okay. Great. So we talked already about scale, so I'm gonna do this quickly. Remember that sometimes we have data that doesn't really plot so nicely. So here we have data sets that don't really work in spin coordinates, and so we can either write our own scale function, which I am doing here in this example, like scale. This is the scale function definition here. Notice the arrow notation. So this is kind of like we take the input and multiply it by 500, and then we apply it here. And then we take the data value that is kind of translated into like pixel space by multiplying it with 500, right? And the result of this is that. And then we talked about that D3 has these scales built in. And these scales are great because we have lots of different scales. They're kind of smart. We can use them also for labeling and access and so on. And so here we have like an example, an X scale. So the scale in the X position here, like, okay, what do we want to do? Is basically just this again. And in the X scale here, we say it's a linear scale. The domain is kind of like our input data space, right? Like we can define this, but it's often useful to define this based on the data. So we're saying our bars start at 0 and they go to the largest value in our array. So d3.max. And then here we define the range, and the range is pixel space, right? This is like what we want to output. And so we want to, basically what we're saying here, this value, the largest value, should map to this value to 700, right? The largest value in our array should map to 700. And the smallest, well, actually, and 0 should map to 0. Okay? And the smallest value will map to some interpolation in between there, right? Okay. And then the call here is very simple, just as before. Instead of directly calling D for width, we just call X scale of D, right? That's the whole magic about that. And so we then talked a little bit about clamping. I don't think I have to go too much into this here, but clamping essentially allows you to kind of like, if you have something that would be overflowing, you could clamp it, but then you have to be careful. Like this is overflowing. If I uncomment this here, then you will see that the overflowing is truncated. But I also mentioned that this is kind of like, it works, but it is dangerous because you have to make clear that this bar has been broken. So any question about scales? Because I'm talking more about scales, but this was like the basic example. So if you have any questions about range and domains. Okay, great. So now let's look at this example here. This is getting more complicated by the minute here. We have here like a bar chart that has both negative and positive values. We are using a redundant encoding of the bar length and of the color. And we're using D3 scales to determine which color a bar should be. And we're using D3 scales to determine which length a bar should be. Okay, so let's look at how we do that. Let's see. First, we have our X scale here. That is like a linear scale, just as we saw before. We take, in this case, because it's now both positive and negative, we are using D3.min data to D3 max data for our domain, right? What could be a good alternative for that here? Like I could take the largest absolute value and do a negative version of that for min, and then negative version of that, a positive version of that for max, right? Then I would have a symmetric chart. If the data is roughly like that, that might be slightly better. I'll show you like an easy trick on how to do something like this later. But in this case, since we have positive and negative data, if we do min and max, you see that these are not actually, like this here isn't exactly in the middle, but that's okay, I guess, for this bar chart here. Okay, and then we have our color scale. So this is the first time we're using a scale for a color. And it's actually also just a linear scale. And we are also using the same domain definition with one exception. Here we want like a divergent color scale, right? We want the red bars to be negative and the blue bars to be positive. And to do that, we need to put in an array here for our domain that has 3 interpolation points, right? We have the minimum, the neutral point, 0 in this case, and the maximum. And so we have those 3 elements, and then we have to map this to 3 colors. And I'm saying here, dark red, light gray, steel blue, right? And so now the smallest value will be exactly dark red, the largest value will be exactly steel blue, and anything in between will be either light blue or light red, depending on where the data value is, right? And so this is actually like super convenient, right? Because like implementing this from hand is not that easy. It takes definitely a couple of lines of code, and you can do this with 4 or 5 or 6 points, how many you want, right? So you can put any of those in, and it will work. And then really this here is fairly boring, right? Well, there's a little bit of stuff going on here about it's a little bit harder to, like, you have to distinguish how you draw the bars, like because you have to place a bar, you have to specify its x position and its width, right? So I can't specify negative width. So I have, if it's positive, I start at this point here, the 0 point, and draw it in the width. And if it's negative, I have to calculate my starting point first and then apply the width, right? So that's what makes this here a little bit more complicated. So where is that? So here, this is our x function d, and like here we turn an x scale, which gives us the minimum of 0 or d, right? So that basically means whichever is smaller. If a value, if d is positive, it will be 0, and if d is negative, it will be d, right? Then our width is kind of like constant, but since we have this scale that goes from 0, like from negative to positive, we now actually have to do absolute value of x scale d minus x scale of 0, right? So that's just because otherwise our bars would all start like be as wide as if they would start from the lowest value instead of from 0. So this is just like basic math here. And then this is the result you get. Well, actually, the interesting part here, well, not interesting part, but the relevant part for the color scale is how do I specify color? Well, it's super easy. I am simply saying fill, and then I pass in my D by running it through the color scale function, right? And so the color scale function here will return a hex color value, and that is then applied for the fill. Okay, so now we don't know what the values are in this bar chart, right? So earlier we had labels, but very often we also want axes. And so here's an example with axes, the same example. And these axes are also nicely done with D3, and they are synced nicely with scales. So most of this example is the same. This here is the new part. And I'm simply saying let x-axis equals d3.axis bottom. So the axis bottom tells us it's an axis that is styled so that it appears at the bottom of a chart. There's, of course, an axis top, axis left, axis right. And then we set the axis to the scale, because that is kind of like supernatural, right? The scale knows exactly what is the range that I want to draw in. And therefore, setting the axis to the scale like makes the axis exactly know what data it should expect. How it now knows everything, right? It knows the input data range, and it knows the output domain. The input domain and the output range. So, and we could also do like a color scale like this, but I'm only doing like a bar width scale here. And then the only other thing we have to do for this axis is this here. We do like on the SVG, this is not a selection, right? This is, by the way, another way you could use D3. There's no data binding. I'm simply appending elements, right? And I'm saying svg.append g, and then call x-axis. And this call x-axis will return an axis object that will go into the SVG here at the bottom. Okay, and then this axis is rendered like this. Okay, so that's simple. It's not all that beautiful. I can do a little bit more styling, and I could create a chart like this. And now this is like a bar chart that starts looking like something, right? So here, notice we have a background here. We have nice padding on both sides. We have a symmetric scale. It goes from -1.4 to +1.4. Notice that this bar here like doesn't actually go all the way to over here. So we did something magical with the scales here. And then I also made the scale axis here green, just for fun, to show that we can actually style these axes. And then notice that here we had some weird ticks, right? There's 1.2, but then there's another little tick, and then here 1.2, and this runs over. All of this is gone here. We have beautifully readable scales that like pick nice intervals by themselves, and all of this is fairly easy to do. So there, here is like a few. Well, let's look first at what's going on with the scales. So to make all of this work nice is just add a dot nice to your scale. And then magic happens, and behind the scenes, D3 is calculating like nice symmetry and nice intervals and so on, right? So most of the time, dot nice is a good option. Then for the axis itself, what we do here is we do actually move it a little bit. So we, like initially it just was at the top, right? But we need to now move it to the right place, and we give it a class. So here we use CSS to style the axis, and I have this at the top. I'll show this in a second. But this here is the interesting part, right? Here we're moving the axis to the right position. We're moving it over by a padding that we defined earlier, and then we're moving it down by the height plus the padding, so that that is exactly like here, exactly at the bottom of this rectangle, right? And then the padding here is this stuff on the left and the stuff on the top. And so this is kind of like a nice way of doing like paddings here. Like we can simply take our SVG and then increase the height of the SVG a little bit to have the padding. And then here we like basically take a rectangle, the background rectangle, and we move it a little bit over. And then we simply like in all of these elements, we move them over by the padding. Another maybe more elegant way would be to just like do a big group, right, and to move all of the things at once instead of doing it in here. And then we get this nice nice chart. Okay. Yes. No, but what that does is it gives you the orientation of where the labels are relative to the axis, right? So if I do an axis top here, we can try that out. Where is it? Yeah. Okay. Yeah, never search in a document like this. Okay. Let's see. The axis top. All right. Well, that wasn't actually the good example because you can't see it, but here you can see it. So this was now off screen, but here we should be able to see it. So now you see that the kind of like the axis is inverted, right? It's kind of designed for to be on top, and if it's on the left, the labels will be left of the axis and so on. So that doesn't do anything with positioning. Okay, so now here is like one big complex example. And there's many things to learn with this example. We'll be looking at, up to this point, we've actually always took just the numerical value and bound it to the data element, right? This time we'll take an object and a complex object at that. Then we'll look a little bit about how we can sort data. Then we'll look at how we did some kind of ugly padding earlier. Now we'll do proper padding, like how this actually would look nice. I guess even nicer might be if you do it with CSS grids. How to use a scale with bands to evenly space the bars. This is like another nice trick with scales. How to update a scale, like say scales might be changing. And then, like most importantly, how to ensure object consistency for transitions with the key functions of the data mapping. And that's kind of like something that can bite people. And so our intended result, and as you see, this is a little bit longer. What we want to do is we want to create a bar chart of some food objects. Get this break. Okay, there's some mixed content warning, which is kind of very unfortunate now. Probably just I need to add an S somewhere at here. Yes, this should fix it. Let's hope. Yeah, lucky. So what happened? Why did this break? Because I was using a mix between secure HTTP connection and an insecure connection, which actually was fine when I was testing it on my local browser, but now I'm using the internet, like the actually deployed web page, and that's why I didn't notice it when I tried this out. But luckily, I was able to fix that. That was bad. So we have a data set of, let's say, bulk food objects that you want to sell. We have apples, banana, plum, bread, cereals, beer, and wine. We have certain things here that we can use to sort this chart. So we can sort it by type. So you see all of the fruit, the green ones are on top, all of the kind of grain products are in the middle, and then our alcohol is at the bottom. We can sort this by product alphabetically. We can sort this by weight so that we have the biggest, like the most voluminous stuff that we have in our warehouse potentially at the top. And then we also have like a few different things here going on. We have they're styled by the type, right? So all the fruit are green, all of the alcohol is orange, all of the grain products are violet. So all of this together here is yeah, kind of like a little bit of code, but let's look at the data structure first. So the data structure here is an array of objects. And this, again, looks very much like JSON. So we have our product, tons, and type fruit. And like now, this is what we're using to bind to each element, right? Each group that contains the bar and the text, and the color will be bound to an object of this type. And now we don't actually, if we want to style this, we don't use just D, but we say D dot tons to feed into a scale, right? So we're like accessing a sub element of the object. The product is our label. We'll also be using this as a unique key to identify the object. And then the type is what we'll be using to style the color. Okay, so the first thing we do here is we take this data set and we extract all of the types, because this is like a categorical variable, right? So we're saying like an easy way to do this is to create a set of the types. That means we have each entry once, and now in this types object at the end, we'll have alcohol, grocery, and fruit. Sorry. Okay, then here we have this max with an excessive function. So this essentially tells us when we want to sort something by the max, we kind of look at the tonnage, right? Then here we set up our margins, top, left, right, bottom, and we'll be like, this is also an object array, so we can say margin.top, margin.right, and so on to access those margin. We do some math for our element here. This is here some space for the labels. Let's look at something a little bit more interesting. So this here is a super convenient function, and that we might want to look at this figure that's in this documentation here. Scales have this special thing that's called a scale band. And so if you use a scale band, you can like use this to position a bar or anything like it with padding and with a margin on the left and the right. And all of this math is done for you, right? So you have your range, and then you have some other attributes like the step number, then the padding outer, the padding inner, and the bandwidth. And the bandwidth here would be how high your bars are in Y, right? And the padding inner would be how far they are apart, right? And so if I do this, I can change the number of bars I have. I can do the same chart with 15 and with 5 bars, and I don't have some static padding, but I have some smart padding in here, right? So it becomes an error, and it kind of like looks natural then. And so this D3 scale band is a super convenient way of doing something like this that is kind of like responsive. And so it's also very easy to initialize. We simply say it has a range from 0 to height, and then we specify what our padding is supposed to be. And I think you don't even have to do that. This is just something that I chose to do here. Then we have our color scale, and now we're using actually like a nonlinear scale for the first time. We have a scale ordinal, so that means it's a categorical scale, right? So it takes a categorical value and maps it to a categorical color. And we know that we have 3 types. And I used here, that's what almost threw this up, because I used this external library that D3 provides for color brewer color scales. These are predefined color scales. And instead of like specifying manually a few scales here, I'm simply pulling in this external library of color scales. I'm using the color brewer accent 4 scale. That's like an accent scale. So basically one that has like very different colors of size 4. And I'm only in this case using the first 3 elements here, right? Because I don't actually need 3. So it's totally fine to put in a larger color range if you have fewer domain elements. That's okay. I'm doing like basically like here I'm styling the action. So here everything here, like basically everything that I could do before is done. Everything that I define that is static I did before, and then here I have my execute function, and here from here on out I'll do everything that is dynamic. Is a question? Yes, yes. I'm not, there's no, this Y scale here, at this point here, it's not completely specified because the data might change. And so I'm doing this in the execute function where I actually know what the data is. So I'm adding that attribute of like how many elements are in there in this execute function. But yeah, very good observation. Okay. Here is actually exactly what we just were talking about, right? So here I'm saying the Y scale to these kind of discrete values. So I'm doing like this data.map product, and the result of this is just going to be a list of the product names of the labels, right? And so these are my discrete values, and that's what I'm putting in here as the domain. And now the Y scale, the padded Y scale, knows how many elements to deal with, right? Then this is the most important part, probably, of this particular example. Up to this point, like here, I'm selecting my bar groups, which is where the bars are contained in there, right, nested. Up to this point, we've always just done a data binding and nothing else. That was okay because we only had trivial data structures that only had a number value in them, right? But now we actually have an object in there. And so for D3 to get the animations right and to do the sorting and so on, we need to know which object is which object, right? So if I sort my data array and I want to, for example, I have apples first and then beer later, and then I want to resort beer and apples, if I don't tell the update function of D3 what are the equivalent objects, then it can't do this transition for me, right? The end result will be okay, but it will look like instead of like the transition will, instead of moving an element, well, maybe I'll just show instead of explaining it too much. So if I do this, note, like, remember earlier I had like this looks the same, but earlier when I did change the sorting, the bars were actually moving, right? So the bars moved up, and that's kind of what we want here. But if I do this in a not smart way, notice that the bars suddenly change color and jumped around, right? So that's not what we want. So like clearly that's not a good transition here, right? That's like a nonsensical transition. It's much better to resort the whole object. And to be able to do that, I need to tell D3 which object is the same if I essentially, like, it's seeing the two data arrays completely independently, right? It's just like trying to compare what is my previous data array, what is my new data array. And it can't know what do I consider, like my bananas could change, right? But I need to tell it how, like, bananas is bananas in my next data array, right? And that's what I'm doing here by explicitly specifying what the second parameter of the data here is the key. And so I definitely recommend that you look at the D3 selection documentation here. But the result here is that D3 knows, because of the second parameter, if it wants to compare identity between two elements, it has to look at the d.product attribute instead of at the whole D, right? And the result of this is that this now works again as I had intended, right? So now stuff is moving around instead of suddenly changing label and color and rescaling, right? So that's a much nicer behavior. So that is something that can be like trip you up like when you start working with this stuff. Okay, so here I'm also doing this properly with like I wrap a group around the element that around the two elements, the text and the rectangle that make up one bar, and then I'm translating them by the Y scale. And what else is interesting here? Here is how I use this Y scale to define the height of the bar. I'm saying dy here is Y scale.bandwidth divided by 2. And well, this is for the text. It would be nicer to look for at the rectangle because there's going to be height here. In this case, is very simple, right? It's Y scale.bandwidth because this is kind of like what we like. The Y scale now takes care for us that this is the right size of the bar. The color scale we put in d.type, and this is how we would access a D like and field inside of a D object, right? So we don't just pass in D, but we pass in d.type into this particular scale function here. Then here we have some like animation that here does basically our sorting for us, and then or the animation for the sorting. And then here is the event that we connected that does the actual sorting. So what's going on here, all of this code here is just the different ways, the implementation for the different ways to sort this bar chart, right? So one alphabetically, one by type, and one by the absolute tonnage. So this is really what's going on in here. Then this is changing the data And then this is calling execute again, right? And so after the execute, like the execute is this function that does all of the D3 styling in here, the data-driven D3 styling. Like once this event here is called, it resorts the data, and then it executes this function again with the same, with the updated data, right? And that's where after which the move happens. And like this here is fairly standard logic, right? So I think I don't really have to explain this because it's not specific to D3 or JavaScript or anything like that. So any questions about this? I'm notice this a lot, but this is kind of like also an example that you're supposed to be going back to, right, and looking at, and that's why it's also well documented and has some examples and links to the documentation in here and so on. Yeah.
The data net. Is that function that
Yes. Yeah. So if this were like two labels that are the same, but it's a different object otherwise, right? Like you create a new object, but it has the product label. It will just look at the product label and would consider those two to be the same thing, even if everything else except for the product label has changed. And it would actually do like a nice animation. For example, if I want to sort and I want to switch out the year that I'm looking at, right? This would still work, but we might see some switching, like some animation that would look consistent, but we might also see some rescaling of the bars.
Does it have to be, what are the specifications? Does it have to be a string or could it be a number?
Anything, it's basically a test of object equality, as your colleague here said. So if it's a number, it's easy. If it's a string, it's easy. If it's an object, you need to specify more, right? Like two objects are usually not equal unless they're really equal. I think if it's just objects, it will just be also the order of the array that is being used here.
And then use the set.
Yeah. That's just a very simple way of like, I have fruit here, and I just wanted to know what are all my types in my data set, right? It's fruit, alcohol, and grain products. Okay, great. So we have 15 minutes left. Any more questions about D3 or code? Otherwise, I'm going to switch gear to the perceptions. Right. Yeah. Let's see, the Y-scale domain. So here we have a range that we defined earlier, and then the execute, we define the domain here. This one is, so what was your question? Yeah. So domain is a function that takes in like the input or the range of the data that you have, right? It was usually like when we had linear data, it was from 0 to 100, for example. Now that we have categorical data, it simply, or in this case, label data, it simply takes in all of the labels and then knows I have 10 labels, and so I need 10 ranges here. Like I'm going to have 10 bars, and each of those bars will have a unique position and some padding. That's what this does here. So here, I'm basically just telling it there's 10 different elements. Prepare for that. And I'm doing this with this data.map that looks fancier than it is, right? The result of this will be apple, like apple, banana, beer, wine. That's the list that goes into this, right? So. Okay, great. So let's do a quick switch to perception. So recall, we talked about the eye, and we talked about some kind of like that we usually perceive elements based on some of our background knowledge, and that color is fickle, right? That we have people who are colorblind, and that we have to think about the specific color scales and so on. But there's some things that we do with really low level vision. And we can actually leverage this in visualization design. It's what's called pop-out, also often called pre-attentive processing. It's not completely correct, but it's still a useful term. Basically, we recognize some objects before we consciously understand what they are, right? This is something that we immediately see. Let me give you an example. So everybody immediately saw the red point, right? You didn't have to think about it. Like the red point is obvious. You don't have to look at all of the points and think about, is it red, is it red, is it red? No, you just see the red point. And so hue is like a very strong pre-attentive property. Everybody saw this element here? Like there's one thing that is slightly different, right? So it's not as strong as the color that we had here. Like that one pops out immediately. The next one here, we can also see it pretty quickly. We don't have to look at every element, but it's a little bit harder. So the curvature form is also a pop-out property. So here's like a little thing to get out warmed up again. Prepare to clap as soon as you spot the odd one. Great. Very quick. Took a little bit longer, but everybody about the same time. Yep. Yeah. So everybody spotted the odd one? Here. The point of this chart is these pre-attentive properties, they work by themselves and they work in the absence of other things that are similar in properties, but they don't work in conjunction, right? Shape is a great pre-attentive property. Hue is a very strong pre-attentive property, but you can't combine shape and hue and expect it to be pre-attentive, right? So here, instead of doing parallel processing and looking at something pre-attentively, like why it took everybody so long and why it also took everybody a different amount of time is because mentally what you did is you looked over all of these regions, had different fixations here, and looked and mentally actually compared, is there something weird about this, right? And only when you saw this one that is weird about it, did you consciously realize something is wrong, and that's why this was all slow. So this one here is the one that you care about. And so this is kind of like the pre-attentive properties are not valid for conjunction targets. So they don't have like a unique visual property. And so this here is kind of like a summary slide. The flicker here is a little bit broken in the GIF. But essentially you have orientation, you have length, you have closure, you have size, you have curvature, you have density. So here we perceive this denser cluster quickly, pre-attentively. With hue, we have color value and brightness up here. We have flicker and direction of motion. And actually those two here at the bottom are also very strong, right? We are very tuned to perceive things that that move and move differently from everything else, right? Because evolutionary, that is of course a great trait to have to see when the tiger is approaching you. So this is useful for target detection. So we can like very quickly detect the presence or absence of a target. So for example, this is what's going on if you have a Wikipedia page open, you hit Control F to find something and you search, then it gets color highlighted, right? And that's why you can spot it more quickly than usual. And then you have boundary detection. So in the, I think I have an example here for boundary detection. So you can make out where does a property change very quickly. So here, like the red ones here versus the blue ones, and then we can do number estimation, right? We get a very good sense of how many elements have a certain property. If I showed you 5 red dots, you would immediately know that there's 5 red dots, right? Or like ballpark 5 red dots. To precise, you would have to count, right? And so region tracking, if it moves, is also possible with these pre-attentive properties. And there's this hierarchy of pre-attentive features. Hue, as I said, is very strong. So here we have this hue separation. Here we have this with shapes. Here we have kind of a mix of like the shapes mix, but we nicely perceive this boundary still. Here the colors mix, but the shapes are separated. But this is less easy for us to perceive, right, as a boundary, because the hue is kind of more dominant here. It works, but it's not as good as this example here, right? And so how can we leverage this pop-out effect? It can be used to draw attentions to areas of interest, and it can be used to express similarity in group memberships. But the thing is, if you want to use this, you have to be careful about it to design it. So for example, you can't, you must avoid conjunctions. And basically that often means that you should be very like stingy with using color in your visualizations. If you want to use pop out, if you want to use color for pop out for highlights, you can't, this isn't going to be very effective if you have like a super colorful visualization, right? Because then it's not going to pop out. And so that's why, like I, for example, like to design with minimal color, because then I can leverage color to like draw your attention to something that I care about. So here is like, we had a couple of these things already, but change blindness is slightly different from attention blindness. And so change blindness is an effect that we don't tend to not remember details of an image across separate scenes, except for areas of focused attention. And if we have some interruption, like remember in the very first lecture when I had this like this old man that was giving directions, right, and the person replaced them. That's kind of like an explicit interruption, right? And then they actually didn't recognize this change. And typically the theory is this is not like a failure of the vision system. We actually can see all of these changes, but we don't pay attention, we don't remember them. And so what do I mean by this? Something significant is changing between two instances of this picture here. Raise your hand when you can spot it. You have like 5 people so far. No, still less than a quarter of the class. So what you're doing to spot this is you look at every segment of the picture, right, and notice and look very closely of whether there's something different. Let me point you to it. So I can actually make it without the interruption. You can spot this, of course, very quickly. Here's another example. Raise your hand if you can see what's changing. It's very essential for the functioning of this object. The engine. So yeah, there's many different theories what's going on. I don't need to go into this, I guess. But what is influence? If I tell you, hey, pay attention, and really try to find it, of course, you're going to get better at it, right? If I didn't tell you, pay attention, you would never saw, like none of you would have seen the box or the turbine beam going missing, right? Here's another example. This one here is not rapid, but it's gradual. And now something has really changed. Anybody notice it? One person. Okay, I'm gonna run it again. The video might not be running. Yeah. So just pay attention to this corner here of the field. Okay, I'm gonna step back. See the corner here? And it's actually like, oops. You play the video here, the corner will disappear gradually. And we don't notice it because it's a very subtle change, right? And so something here is going on. And here is similar, like there's another example. I'm gonna jump over this. Here is one beautiful scene from the 80s. That anybody notice a change? So look at the lady's shirt here. It's turning red. Another thing is attention blindness, and here is like a fun example.
Perception test. Watch this brief silent movie, and then I'll ask you some questions about it. You saw a person get up from a desk to answer a phone, right? Did you notice anything
Anybody notice
changed during the
something?
video?
Sure.
The video had two different
actually
actors wearing
two
different
different people.
clothing. Watch it again. Most people don't notice the change,
Okay,
a
so let
phenomenon.
me just see whether I can, for the next one I need audio and I need to switch this to the room.
This is an awareness test. How many passes does the team in white
One person saw it.
The answer is 13. Did you see the moonwalking there?
So this is like a campaign for road safety. But very nicely illustrates the point. So I'll continue here next time and I'll talk about why this is actually relevant for visualization. Thanks everyone. Have a good weekend.